phase of the moon. This is the next thing. Sometimes you get higher tides because the phase of the moon affects it. Okay, so the phase of the moon affects how high or low a tide's going to get. Let's get into how that works. Sometimes you have what's called spring tides, okay? And those are when you get really high highs and really low lows. And that's because the sun and the moon both influence tides. The moon's influence is about 3 times more than the sun's, though. The sun's gravitational pull is stronger, but it's so far away. So the spring tides are going to go way up and way down. You can think of it in terms of, it springs up and springs down. Boing, boing, boing. That's a way to remember the spring tide. And this happens when the sun and moon line up. Their influences line up. Okay? And we're going to draw a picture of that. So, okay, the spring tide. So on your paper, please write spring tide. Again, this doesn't have anything to do with happens in spring, like winter, spring, summer, fall. It happens to do with the tide levels, spring up and spring down. Okay, think of it that way. And so, what do we have here? We have the sun. So here's the sun. Oh, I don't know why I liked giving the sun sunglasses. Just, I don't know. Okay, so there's the sun. Well, make it look like the sun by writing sun. And then Earth here. Okay, so we got the sun and the Earth and the moon. Now let's make this a little more earthy, I think. Let's call, okay, I don't know. Here's like Florida and South America, and here's Europe and Africa. Okay, so here's Earth. Oh, I know how we can make it look like Earth. Let's write this underneath it. Wow, now suddenly it looks just like Earth, doesn't it? Okay, and so when you have the moon in line with the sun, the moon is causing the tidal bulge, and on the other side, and the sun, even though its influence is about 1/3 as powerful as the moon's because it's so much further away, its influence adds up with the moon's influence, right? And so they're in a line and it adds up. So this is the moon. And now think about what would the phase of the moon be from what we've learned. If you're looking at the moon and it's lined up with their, okay, yeah, they might have a solar eclipse, but let's say it's not in one of the nodes and it's not a solar eclipse, that would be a new moon. So during the new moon phase, with a moonless night, that would basically be the when you have the highest highs and the lowest lows. That's when you want to go out and go, with your gear and go try to catch, clams or whatever out in the beach. Okay, and then also though, when it's on the other side during a full moon. Okay, this is still the moon. So the full moon would also have the highs and lows that the moon is making are being added to by the highs and lows that the sun is making. So here you have the highest highs and the lowest lows, and this is going to be, you got a high tide over here and a high tide over here. And so this is where you're going to have the highest highs and the lowest lows is during a new moon phase or during a full moon phase when they're in a straight line, because the influence of the tidal forces from the moon and the tidal forces from the sun accumulate. They add up on each other. All right. A graphic of that would be like this here, where here, when they're lined up, that's when you're going to have the spring tides, okay? High tide here, high tide there. The combined gravitational pull of the sun and the moon. All right. Now, what happens, though, when they aren't in a straight line? Let's say that the sun is over here and the moon is up here because the moon's going around, right? That is called a neap tide. Spring tides I remember because they're like spring, spring, boing, boing. Neap tides I always remember because it sounds sort of small. It's like neep, neep, neep. I don't know. It just sounds like a small little sound, right? Sometimes the tidal range is very slight. These are called neap tides. Neap, N-E-A-P, neap. Go ahead and say neap. Neap. And these happen during the quarter moon phases, and then when it's about 90 degrees, their influence kind of cancels out a little bit. What happens is on the side of the Earth where the sun, I'll use this one here, where the sun is trying to make a high tide here, if the moon's over on this over here, it's trying to make the high tide where the low tide is for the sun. And so it subtracts from it. The sun's influence subtracts from the moon's influence. Since the moon has the most influence, what the sun does is kind of modifies how high or low the tide's going to be based on whether it's adding its tidal effect, its tidal forces, or whether it's subtracting its tidal forces, okay? So neap tides would happen in the quarter moon phases, third and first quarter. So let's draw a little diagram. Okay, now the neap tides is opposed to the spring tides. So here you have the sun over here. I don't know, here's the sun, keep an eye on you. Sunshine on the earth. Okay, so here's the earth. And we have the sun, you know, it's trying to do its thing to make tides happen, right? But of course, the moon has greater influence than the sun does. Now, if the sun's trying to make its influence go this way, and the moon's trying to make its influence go that way, they kind of cancel each other out a bit. Now, the moon has a stronger tidal influence on the earth, so the moon's going to win, but any influence of the sun is going to get subtracted from that of the moon, okay? And so when's that going to happen? Okay, here's like the new moon, waxing crescent, first quarter. So when it's at 90 degrees angle, right? 90-degree angle where it's first quarter. And so I can write. Okay, so new moon, waxing crescent, first quarter. What's that? Waxing gibbous, full moon, waning gibbous, third quarter. Okay, so here's third quarter. So in both of these positions, right, here and here, the influence, the tidal forces from the moon are going to have the tidal influences from the sun kind of subtracting from it. So where the sun's trying to have a high tide, the moon's trying to have a low tide. Where the moon's trying to have a high tide, the sun's trying to have a low tide. And so what you end up with is, yeah, you still have a high and low tide, but they're not as dramatic. They're a lot less. The lower highs and a higher low tide, okay? And those are called neap tides. N-E-A-P. Neap. I'm not exactly sure where that comes from, but it sounds like a small thing, doesn't it? Okay, so there we go. There's the neap tide. So that would be a neap tide. Now, here's in another picture here. Spring tides are when they're lined up. Neap tides is when they're 90 degrees from each other. Okay? You have more extreme ranges for spring tides than neap tides. Now, here's an interesting thing. Since this is an astronomy class, after all, I am planning on getting to some cool astronomy stuff like black holes and stuff. I got to make a judgment call on time for the course of the school year because we're almost halfway done with the school year. But I'm going to stick with astronomy a little bit past just this. A black hole, you probably heard about. A black hole, its gravitational pull is so strong that even light can't escape. It's really very... it's a huge amount of mass condensed into a small amount of space, okay? He could have like the mass of the star, of like the sun, crunched down to something the size, well, actually it's called a singularity. It's so small, it's infinitely small. It just collapses. It keeps pretty interesting stuff. Now what happens, sometimes you'll see in a science fiction movie, oh, he fell into a black hole and then came out the other side. Would that be possible? Could you survive falling into a black hole? No, you couldn't survive it. For one thing, you would be crushed down to smaller than the size of an atom. And I don't think that your brain would survive being crushed down to the size of an atom. I mean, that wouldn't work. But another thing that would happen is as you got close to it, suppose Baby Yoda was falling into a black hole, okay? Let's say the black hole's over here. I don't really have anything handy to represent a black hole. But it's down here. The Remember, the gravitational pull in a black hole is spectacularly huge. It's enormous gravitational pull, stronger than you get on the sun, right? And if you get really close to it, the since the let's say that you're almost at the black hole and your feet, let's say, are 3 feet away from it, and your head is 6 feet away from it. Well, the grab means you have twice as much, not twice, you have twice as much distance, but 4 times as much gravitational pull on your feet, and it would stretch a person out because the forces would be so incredible that they're called the tidal forces, right? In a black hole. Now, you don't have to read all of this text here, but this is like the best one that had the words and showed the picture. They call it, the technical term that physicists actually call it is spaghettification. The person would be stretched out like a piece of spaghetti as he was quickly drawn into the black hole. So that is actually tidal forces that would tear the person apart. That's what it's called. In astronomy, they have tidal forces as well. And so this effect of a neap tide and spring tide with a full moon, another thing caused by the full moon. Oh, don't be scared. Okay, I don't know. I wore my Halloween tie today.